What's up, everybody? Gonna do review problems here for you. Number one, before we get started, I will continue this tradition of talking to you about my dietary, I don't know what word, dietary inputs, the things I eat. Here's a quick story. I was gonna go to Snarf Burger and get a lot of hamburgers and a milkshake, but apparently they don't exist anymore or something. I'm not really sure. It was chained off. So I decide, well, why don't I get some Mexican food? Mexican food is delicious. So I called up an order to Casa Alegre in Louisville. And I'm driving over there, and I almost get into a car accident from some crazy person who does not yield when they were supposed to yield. Luckily, I survived. I'm in the parking lot waiting for my food. I'll show you how it looks in a minute. But before I do, let's talk about this problem. Problem number 1A. We want to write the equation of this graph. Notice what has happened to this graph. Since it does not have this tippy point right there at the origin, 0, 0, I can recognize that this thing has been shifted to the right by 2 and has been shifted down by 1. So think about how we do that. We shift a graph to the right by 2 when we have x minus 2, like that for our function, whatever our mother function is, and we shift it down by subtracting 1 at the end. So what is this mother function? Well, this is the bird graph. Notice it is not absolute value because those lines are not straight. They are curvy. So this is going to be e to the power of 2/3. But what other transformations have we applied? We have flipped it down. So that means there is absolutely a negative in front of there. So the last thing we need to check is there some sort of coefficient in front that is stretching this graph? And how do we check it? Well, normally on our bird graph, or pretty much any other graph, when we go over 1, we should go up 1. That's clearly not to scale, but that's the idea. So what happens here? When I go over 1, how far am I going down? 1, 2, 3. So that's telling me that this is negative 3 times x minus 2 to the power of 2/3 minus 1. This is our function, and that's pretty much it. We don't need to identify domain and range, but we could if we wanted to. Domain would be all real numbers. Range would be all real numbers that are less than negative 1. Holler, done. I'm going to go check on my food.